During the last 25 years, CO2 has been the dominating theory trying to explain all climate variation. However, if we look at historical climate, there's absolutely no doubt that the sun has been extremely important, and you cannot ignore it.
Now, how do you uncover past climate? We have to rely on signatures of climate, fingerprints called proxies. That is something in the environment that's sensing what the past temperature or rainfall was like. You can look at bogs, for example, and find information that says in the past it was warmer in some regions because there are particular insects or pollen there that doesn't appear during cold times. You can look at ice cores and make a chemical measurement that relates to what the temperature was going back in the past, and look and reconstruct the past climate for that area.
It's like the work of a detective. You find, indeed, dead objects, and the first step is to identify them. We use radiocarbon for dating our peat deposits. And radiocarbon is formed under influence of cosmic rays. And when there are changes in the cosmic ray intensity, then we have also changes in the production of radiocarbon. And so we made the link for the past between cosmic rays and climate. And then I heard about this Hendrik Svensmark from Copenhagen, and he was telling how cosmic ray intensity changes could influence cloudiness and therefore could influence climate and climate change. This is a peat profile from the eastern Netherlands. And you can see in this profile, in this sample, you can see the shift, the climate change expressed in the color. This darker lower part has to do with warmer, drier local conditions in the bog. And suddenly there was a shift to wetter conditions. But at the same time, we found that the radiocarbon content of the atmosphere showed a sharp increase at this level. And that has to do with a sudden decline of solar activity, so that more cosmic rays penetrated to the Earth, in the atmosphere, more clouds were formed, there was more rainfall, and you can see the reaction of the bog plants. I'm looking at the past. I have strong doubts about what's going on now, and some people think that they can manage climate and climate change. And I have strong question marks on that sort of behavior, because maybe there is nothing to manage. Maybe there is natural climate change going on at the moment. And is this indeed enhanced greenhouse effect? Or is it mainly changing solar activity?
Yeah, and look at the warmth here. Right. The temperature over the last several hundred years has swung up and down, and when we look at the changes of the sun's magnetism, they match up fairly well.
We're at the Dead Sea, and we're going to a place called Nahal Pratzim, which is one of the nicest places where you can see climate variations taking place here. People have this conception that the sun is this constant ball of gas that doesn't do anything. This is wrong. In reality, the sun can sometimes be very active. It's this solar activity, this dynamic nature of the solar activity, which affects the solar winds and which affects the cosmic rays and which eventually affects climate here on Earth. Climate variations over the past decades, centuries, millennia can be reconstructed from many different places around the world. Here we're now located in the Dead Sea, 20,000 years ago, the Dead Sea was higher, it was much wetter, and the level was higher than where we are standing. And every year there were yearly deposits which were left on the lake's floor. And here we can see those annual deposits. Basically, during winter, the dark deposits are left, and during summer, the bright deposits are left. So the ratio between the dark and the white bands tells us a climatic story. It tells us how the climate here varied during the years. On these timescales of centuries and millennia, you can reconstruct what the sun was doing using cosmogenic isotopes like carbon-14. What's interesting is that this carbon-14 is directly formed by the cosmic rays. So this and other results or other measurements from around the world tells us that the sun is affecting the climate. This link between solar activity and climate on Earth, it's not hypothetical. You just see it in the records. When the sun was more active, you indeed see that it was warmer on Earth, and vice versa. "300 years ago, for example, the sun was not very active, and we were in the height of the Little Ice Age when it was cold in many places on Earth. 1,000 years ago, the sun was active. It was as active as it is today, and it was warm everywhere. The Vikings could map all of Greenland because the northern shores of Greenland were not frozen. Then before that there was a cold period and a warm period and so on. And the last of these warm periods is today. Today, for example, the sun is in an active state, and we see that the temperature is higher. Most of the people today think that most of the climate change is because of CO2. But this is wrong. Most of the warming over the 20th century is because of the sun.
If we look at Earth from space, we will see that about 60 to 70% is covered by clouds. If more cosmic rays comes down, we will have slightly more clouds. And you can imagine the opposite, fewer cosmic rays, we have a little fewer clouds. Instead of thinking of clouds as a result of climate, it's actually showing that the climate is a result of the clouds, because the clouds take their orders from the stars. After we found the link between cosmic rays and clouds, we only knew that it was a total cloud cover, but I had to find out what type of clouds. And at some point it became possible with a new data set to investigate exactly this. And at that time I got help from Nigel Marsh.
Yeah, I sent that figure to
He helped analyzing these data. And much to our surprise, we found that the link is actually to the low clouds. So it seems as if cosmic rays are changing low clouds.
All right, I'll speak to you later. Yeah, bye. Bye.
This was a surprise Because if you look at cosmic rays, you will find that you have more cosmic rays high in the atmosphere, and therefore many people said the effect should be in high clouds because you have more cosmic rays there, and high clouds are usually warming the Earth's climate. And people thought that the whole theory must be wrong because it can only be high clouds. But it turns out it is low clouds. And that is very, very good news for the whole idea.
When I got this result, I thought the correlation was much better than I ever dreamed of.
If you decrease the amount of low clouds, it will be more heating down to the ground. And in particular now this new work that shows that it's only the low clouds that changes, which makes it very interesting. There's still a mechanism to explain this that's missing. And it's now important to do the research to try to understand this mechanism.
There's a fairly large fraction of low clouds, a large part are responsible for a large part of the cooling caused by these clouds.
The reason low clouds are so important is that they actually reflect a lot of the sunlight back into space. I mean, we know them when we travel in airplanes. These are these monotonic scenes that we see over the oceans. And they are white because they are reflecting the sunlight back into space. And you can imagine if you change the amount of low clouds, you change the amount of energy that the surface gets. That means that low clouds have a strong cooling effect on the Earth's climate. So if we have more low clouds, climate will become colder. And if we have fewer cosmic rays, we have fewer low clouds, and the Earth becomes warmer.
You mean with the ISCA data set? Yeah. It's in the infrared, what we've been looking at.
That's interesting. Okay. Well, I first heard about Henrik Svensmark's work when we became interested in looking at how aerosols, or very small particles, are produced in the Earth's atmosphere in the first place. I mean, this is important because all clouds are formed upon aerosol particles that are in the atmosphere.
So the satellite is looking at a specific parameter.
In terms of the work that we've done, what we've found is that the galactic cosmic rays are capable of modulating the aerosols, or small particles, in the lowest part of the atmosphere. In fact, we can show that the aerosols produced by galactic cosmic rays are significantly modulated in the lower layer, which contains these clouds that produce a cooling effect on the Earth. What we don't understand at this point is exactly how and why they're formed. Every cloud droplet that's formed is formed on a particle initially in the air. And so it's absolutely crucial to understand how these particles come about and what their properties are. Otherwise, we can't ever hope to understand clouds and their behavior.
And that's where cosmic rays actually might come in. Because what do cosmic rays do when they enter the Earth's atmosphere? They produce small ions.
Oh yes.
So
It is the belief that these small charges help forming these small specks or aerosols in the Earth's atmosphere.
Whereas most people would think that since there's water in the atmosphere, that naturally there'll be clouds, but that isn't true. The only way that clouds can form in the atmosphere, in our atmosphere, under normal conditions, is to condense onto an aerosol or existing particle in the air. Every cloud droplet that's formed is formed on a particle initially in the air. All clouds are formed upon these aerosols. And so it's absolutely